Hi. So we are gonna, I think we're gonna learn about running .NET workloads on IBM Z. Is that right?
That is right. Let me bring up my presentation. Here we
And
go.
where are you joining it from?
So I'm joining actually from Germany, the beautiful city of
Nice.
Tübingen in southern Germany near Stuttgart.
Wonderful. Wonderful. Happy to have you here. All right. I'm gonna bring in your slides. All right. All right. All yours.
Okay, thanks, Nish. So as you said, we are talking today about .NET Workloads on the IBM Z platform. And first of all, I would like to thank the .NET Conf organizers for giving me the opportunity to share that topic, which may be a little bit different from what you're usually talking about at this conference. And I'm sure that there will be some amongst you that are even asking, well, what is even IBM Z in the first place? I may have never heard of that before. I may have never used that. And so before I spent the major portion of this talk about what we did with .NET on IBM Z, I would like to spend just a couple of minutes on a bit of an introduction. What is even IBM Z, and to answer those questions. Now, first of all, maybe even you think you never heard of it and you never used it. Maybe you actually did hear of it, and I'm pretty sure most of you actually have been using IBM Z in one aspect or the other, even without actually being aware that you do so. And IBM Z is actually not a new thing. It is one of the systems with the longest history in computing that we have today. And it started in the 1960s. Back then it was called IBM System 360. And one place where you may have heard of that is, and there were a couple of movies about that recently, on the theme of the Apollo moon missions back in those days. And they used IBM computers and ground control to perform orbit calculations and other things like that. And those actually were IBM 360 machines. Now, this machine doesn't look like that anymore, filling up a full room. Today's IBM Z looks more like what you see here on the right, which is our current model, the IBM C15. But that is, in fact, a direct successor across many, many generations of machines, but it is a direct successor of that machine. And, well, you may say, well, I still haven't used neither of those. Well, if you ever did a credit card transaction, or if you ever booked a flight, or most likely if you made a bank transaction, then at some point that transaction will more likely than not have been processed by one of those IBM Z machines. In fact, if you look here at the right-hand side, most of the world's top banks, insurers, airlines actually use IBM Z to do their transaction processing. Now, let me just spend a few words on what makes, why IBM Z is being used for these purposes. And let me point out just three attributes of the IBM Z system and the IBM Z hardware that is the reason why this is used in that space in particular. So the first is it has been really designed from the ground up over many, many years as a platform for large-scale data serving and transaction processing, and that you can see in the large number of I/O channels with dedicated logic that offload all the data processing from the main processors, which run the business logic. But then there is also the scalability and reliability of the system that makes it predestined for applications that are really mission critical. Like you don't want your bank transactions to go wrong or your credit card transactions to be missed somehow. And the IBM Z hardware is designed from the ground up for high availability and resiliency. So starting from error correction everywhere up to things like if there's some uncorrectable error during processing in the CPU core, the system uses a checkpointing logic that would allow the missed work to be picked up by a different spare CPU core in the system transparently without the application or even the operating system even noticing. And it's not just about unexpected outages, it's also about expected outages. So for example, if you need to update the microcode firmware of the machine, you can do that without bringing it down. Or if you have to replace hardware, you can do it without bringing the system down. And the scalability allows you to run very large single system applications using hundreds of cores, many terabytes of memory, but you can also split up the machine via partitioning and virtual machines into thousands of different tasks at the same time. And finally, the machine is also built up for highest level of security and compliance. So for example, it has a hardware security module that is used by banks to store their master keys, which is the only in the industry that is certified at the level 4 of the FIPS 140 standard, which provides for the highest standards of tamper-proofness, even in the presence of an attacker that has access to the physical hardware. So what is that system actually based on? Just a few words on the actual processor architecture, because that becomes interesting and important when we talk about applications, compilers, and bringing something like .NET to the platform. So the IBM Z system actually implements its own processor architecture, so which is called today Z architecture. And again, this was initially designed back in the 1960s. And the architecture we have today is its direct successor of that architecture that was designed in the 1960s. And to the extent that some of those programs that would run on those systems back then can actually still run and execute on today's hardware. Now I'm not going into all the details, bits and pieces of how that architecture works. By today, it's been, of course, extended and enhanced many times, and is today has a significant instruction set of over 2,000 instructions, as vector instruction sets, and so forth. You can read all the details in the principles of operation, which is the instruction architecture specification. Let me just mention that within even that chip design, we have a number of capabilities that are the foundation for some of those aspects that I talked about earlier, from those error corrections, from hardware assists that make the virtualization possible without high overhead. We can even do nested virtualization. So you have a virtual machine inside a partition and have both levels fully accelerated by hardware with near zero overhead. As a final comment, let me just point out, so this is what you see here is the chip in our current machine. If you're interested in more details, you might want to look out for our presentation at the Hot Chips conference this year, where we introduced the next generation chip that will go into next year's systems, which has been redesigned from the ground up and also includes AI acceleration capabilities. But for now, enough talk about the hardware. Let's talk about what is running on IBM Z. And we, of course, have our traditional operating systems with our main operating system on the platform being called ZOS, which is where many of these transactional workloads by banks, insurance companies, and so forth run. There's a couple of other operating systems that you can choose as well. But what I want to talk about really is Linux. As you know, Linux runs everywhere, and Linux runs from the smallest embedded system to the largest supercomputer, and Linux also runs on IBM Z. It's been available since about 2000. You can choose distributions with enterprise support from either SUSE, from Red Hat, or from Ubuntu, with full support for IBM Z. Now, why would you run specifically Linux on our platform? Well, there's a couple of reasons why you might want to do that. The first reason, obviously, is, well, just simply it's a way to combine the great hardware capabilities of our platform, starting with the performance, with the scalability, with the reliability and security, and combine those capabilities with the vast software ecosystem and the rapid pace of innovation that can be found in the Linux ecosystem. So you can take your Linux workloads and just run them on our platform. And one good example for that is, of course, the Red Hat OpenShift platform, which we support now for about 2 years, which you can run on Z, where you can have your cloud operations model and cloud deployment model, but still have all your data in-house on premises, on your own machine that you control if you're concerned about maybe data that should not leave your control. And but it also enables you to pursue a hybrid approach where you say, okay, I have some workloads that I really need to keep in-house and other workloads that can also run in the public cloud. And with a hybrid approach, you can mix and match and have control over your whole application space, whether it runs on premises or in a public cloud within a single control plane. The other option is, of course, if you already use ZOS, and that's a typical use case for some of those customers like banks, when you already have ZOS where your main transaction data is residing and is being processed, you may also want to run Linux co-located on that same hardware using the virtualization capabilities. So you can have, for example, that application using the most recent software innovation that is found in Linux and run it on the Linux side and have it very rapidly and with low latency access the data that is kept on your ZOS side. Recently, we have, in fact, allowed customers to go even beyond that with a feature called ZS Container Extensions, which basically allows you to run your Linux workload directly inside of ZOS. So if you're familiar with that, like on the Windows side, there is what they call the Windows services for Linux, which is a similar approach. We have Linux directly running on the Windows. This is basically the same approach under ZOS. On the other side, we have some customers who actually don't have and don't need ZOS. You just want to run Linux-only workloads on the platform. And for these, for about 5 years, we have a special model of the IBM Z, which is called the Linux One, which is the same hardware, but it's packaged and optimized to run Linux-only workloads. Now, talking about running Linux workloads. Well, Linux is Linux, and Linux on IBM Z is very, very similar to Linux on Intel or any other platform. But of course, since I mentioned it is a different processor architecture, it's not Intel, it's not ARM, it's not Power, it's its own processor architecture. So everything that is compiled to native code, you need to have the application development environment and tooling available to do so. And that is actually our role and my responsibility with my group to ensure that we have all these capabilities available to allow you to run your applications on Z. And we already have support for a large number of languages and environments, and I'm not going through all of them. But, and that's where we get back to the topic of this conference, there was one major language ecosystem that we until now did not support on our platform, and that is .NET. But fortunately, as of right now, this has changed. And let me talk about how we went about that. .NET has a long history, which I'm sure you will be familiar with. I'm not going into all the details. Just let me point out that none of the various flavors and instances of .NET have ever supported IBM Z so far. However, we did have support for IBM Z in the open source reimplementation called Mono. And that has actually been available for a while, but not in sort of the official .NET. That has changed now with .NET 6. And what did we need to do to get there? Well, let's look at what is all in the .NET 6 deliverable as you can download it today. Well, it has a runtime, which is the virtual machine, the VM implementation, plus the just-in-time compiler that generates native code. And .NET 6 actually, just like .NET 5 already, has two variants of that runtime. It has a curricular variant and the mono variant. And depending on the platform and the architecture, some use the one and others use the other. We have a set of base class libraries that implement all those APIs that .NET applications can use and can rely on. It has the software development kit, which consists of the compilers for C#, F#, Visual Basic, and tools around application development like MS-Build, NuGet, and a whole host of others. And it also includes the ASP.NET Core, which allows you to write web applications in .NET. And all this needs to be available on our new platform as well. Now, fortunately, many of the components actually are written in C# as managed code, and therefore don't really require a whole lot of porting. With the one big exception is, of course, the runtime, because that is the place that actually generates native machine code. So that is the place where the largest effort was required. Now, where are we? As of right now, as of the release of .NET 6, we are fully supporting IBM Z throughout all these core components I just mentioned. We have chosen to use the mono variant of the runtime simply because there was already pre-existing support that was inherited from IBM Z support in the standalone mono that I mentioned earlier. All those changes have been developed in the open source. They have been submitted, reviewed, merged upstream. So if you check out the open source .NET repositories, you can find all those changes. What were those changes about? Well, as I said, the mono backend already had IBM Z support, but it had never been used like in this particular context as basis of a full .NET implementation. So we found a number of issues that needed to be fixed. We found a number of places where we wanted to enhance the performance. One place that I had mentioned before where our architecture is a little bit different from, say, Intel and ARM is that we are a big endian platform as opposed to Intel, which is little endian. And some of the places we found did not work correctly on the big endian architecture, so we had to fix those. And finally, we actually also integrated our platform into the upstream CI. So it is tested twice a day. The current .NET code base is actually built and run on an IBM Z, and it's verified that it's all stays green and passes all the tests. And just to point out here, this was a collaborative effort by our teams at IBM with our colleagues at Red Hat, but also with great support from Microsoft and the .NET and Mono open source communities. So at this place, I'd like to thank all the parties and people who were involved in that effort for their support. Without that, we wouldn't be where we are today. Finally, how can you actually get your hands around it and play with it? Well, that's where our partners at Red Hat come into play. As you may know, Red Hat has actually supported .NET for many, many years, basically since .NET Core was released back in 2015. And .NET has been supported both as RPM packages that you can just install on your Red Hat Enterprise Linux, but also as prepackaged containers that you can just deploy either under Docker or Podman, or you can deploy them into a Red Hat OpenShift container platform environment. And up to now, this has only supported the Intel architecture. But as of Red Hat Enterprise Linux 8.5, which has just been released, this has been extended to include both the ARM architecture and also the IBM Z architecture at the .NET 6 level. So as of right now, if you look at either RHEL 8.5 or if you look at the current Red Hat container catalog, you will find .NET 6 packages and images for all those three platforms. Okay, now enough charts. Let me give a quick demo. So the thing is, it's hard to sort of make an impressive demo on showing that machine because I mean, it's just a server you log into remotely, and logging into an IBM Z Linux instance remotely just looks like logging into any other Linux server instance remotely. So the only thing I can do to prove you that this is actually an IBM Z is to look at the architecture, and you will see the S390X, which is the Linux architecture marker. That actually goes back to one of the prior names, if you will remember from my first chart, where at one point it was called System 390, and that was the time when we first brought Linux to the platform. So that's why the Linux architecture identifier still is S390. So we do have a IBM Z machine here, and it is, it is the latest Enterprise Linux version 8.5, and it runs .NET. Great. So, and you see here, it is the latest .NET 6 with all the support for ASP.NET Core, for .NET Core runtimes, for the .NET SDK, and it claims it is the RHEL 8 S390X platform. Great. Now, what can we do with it? And again, let's do nothing particularly impressive, just make sure that it all works. Well, the first thing you do is you run your hello world. So let's do a .NET new console. And we have an application created. Let's do a .NET build. And it builds, and by the way, this all runs natively on the IBM Z. So the whole compiler runs natively. Here runs natively, and we do a .NET run, and it says hello world. Let's try to change the program to make sure we are doing the right thing here. Let's do hello world from IBM Z. And run again, it will rebuild. And it says hello world from IBM Z. Great. Now, let me show you a little bit more. And the one thing I thought would be interesting to show you, well, what about I have an existing application? How can I make sure it actually runs on the IBM Z platform? And as an example, I used something that I was actually asked for real by one of our customers. That's something that they are using, and they want to make sure that it works. It's an open source .NET application identity server, which is used to manage your identities when logging into web applications. And I just checked it out. That's just checked out from its official home on GitHub a couple days ago when I prepared the demo. And let's just try to build it. Oh, doesn't work. Okay, why does it not work? Okay. It says it wants to build for .NET version 3.1. But on IBM Z, we only started supporting .NET with version 6.0. Okay, good. Let's go to the global JSON and just pull it up to .NET 6. You should be going to .NET 6 these days with your application anyway. Okay, it starts building. What does it say? There's an application host available for runtime identifier. That's weird. I know there is an application host available. Let's look at that project file. Oh, it builds for the NetCore 3.1 target framework. Okay, so that error message means there is no application host for the NetCore 3.1 target framework available for Linux 390. And that is true because, again, we only started supporting it with .NET 6. So I could just change that. I have prepared a patch to do that because, unfortunately, that's not just in the one project file, but in a whole bunch of project files. So I've applied the patch. It's changed to .NET 6. And let's go along with the build. So while it's going through, so you see it's starting to build, it's starting to run its test suite. So far, so good. Let's see how far we get. And as you saw, moving to .NET 6 is one of the things you will need to do in order to run IBM Z, because we don't support any earlier .NET version. But that's probably something you want to do anyway. Oops, we run into another problem. Let's see what's going on there. Oh, it tries to run unit tests. And you see the Visual Studio Test platform gives an exception that something is not supported around when it's just looking what architecture it's running on. And that is an interesting problem. We looked into that and fixed that problem. It turns out that this infrastructure actually checks which architecture it's running on and decides what to do depending on the architecture. And if it finds an architecture that it doesn't know about, it just fails with an assertion. So we fixed that upstream, and the latest and greatest instance of the Visual Studio Test platform actually supports our platform. It's just that, it looks like this doesn't use it yet. And indeed, it has a package reference of a Microsoft.NET Test SDK version 16.2, which is not the latest version. The latest version is 17.0. So let's push it up to the 17.0 version and try again. And you will see that it now continues further. And that is also something that you may see in your applications, that you will have to update your .NET the test SDK version to version 17.0. And you may have, and here you see, okay, there's the first output. That's the unit test output. And it has all green, all passes, no failures. And it is running through. And it's not a big surprise. There's one more failure in there, which we should be running into shortly. And here we are. What's it trying to do now? Oops. It doesn't find a library. SQLite. Oh, it uses the Entity Framework core, which uses SQLite as its database, backend storage. And the SQLite is actually a wrapper around a native library, which is written in C++. And that in that version of the SQLite that this is using wasn't supported on our platform. So we worked with the upstream maintainer of that SQLite package and got a native port to our platform included. So again, the problem really just is that it is using an older version of the Entity Framework here, which pulls in an older version of the SQLite. So again, we need to pull up to the latest and greatest version, which is Entity Framework 6.0, which goes with .NET 6. And if we run through, you will now see it complete successfully. I think in the interest of time, let me move back to the presentation. So we saw that. And let me just summarize the steps that we just did and what you may need to do with your application as well. Most importantly, if your application is not already on .NET 6, move it to .NET 6. If your application, and a second important step, ensure your application actually runs on Linux, because we are a Linux platform, so it doesn't run on Linux at all. It won't run on Linux and IBM Z either. There may be a few specific platform-specific constructs that you may have to address. That's one thing is if it checks what architecture is running on, like the example we just saw, and there may be also some code that does Indian-specific data accesses. Sort of a red flag for that is if your code uses bit converter or APIs like that. That you might have to review. You need to make sure that your native components are available, and the same applies also to all third-party dependencies that your application may have. Now you say, okay, it's great that we can do that, but I don't even have access to an IBM Z. Well, we can help you with that. We make no-charge access available to open source developers for the purpose of porting the applications to IBM Z. If you are an ISV, we have a partner network for ISVs where you provide access to porting resources, including machines and also information and contact persons. And you can also, if you actually just want to run it in production, you can actually acquire IBM Z virtual machines in the IBM public cloud. And with that, let me finish up with the release announcement. So the Red Hat, 5 has been announced and released, generally available just this week. It supports .NET 6 and it supports .NET 6 on IBM Z. Check it out. If you're interested in running your workloads on IBM Z or porting your applications to IBM Z and have questions or concerns, please let us know and reach out to us. And with that, let me go back to Nish.
All right. Thank you so much. That was a very insightful session. Again, I had no idea about IBM Z, and thanks for letting us know about the architecture. And I'm so glad that .NET now supports on those architectures as well. And so I want to ask you, Ulrich, so are you new to .NET, or did you came in as part of understanding or to bring in IBM Z architecture support to .NET, or you have been working with .NET before?
I was new to .NET. I mean, I knew about .NET. I had used like Mono a little bit in the past, but I was new to .NET. So my background is really, I'm very familiar with the IBM Z platform. And as I said, I was working on other compilers on the platform. So I know how to create a compiler for the platform. But .NET was all new to me. I had to learn that.
Okay, how do you find it? Like, I just want to understand your feedback.
Very, 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 very nice, interesting, and I particularly liked working with the .NET community, which has been very welcoming and helpful. So very glad about that.
Cool. Once again, thank you so much for joining us and explaining everything related to IBM Z. So I'll let you go now and enjoy your rest of your day. And with that, yeah.
Thank you. Bye-bye.